For a few days this April, the upper boundaries of Earth's atmosphere will become a high-speed collision zone. We are heading directly into the path of the Lyrid meteor stream. Annual meteor showers happen predictably, but the conditions for watching them do not. The 2026 encounter offers an exceptionally rare alignment between the Earth, the meteor stream, and the lunar cycle. This timeline chart maps the night cycle for the peak window, spanning April 22nd into the 23rd. The moon is a waxing crescent and is scheduled to dip completely below the horizon around 2 a.m. local time. That leaves the entire pre-dawn window completely dark, stripping away the light interference that usually hides the most active part of the shower. What you're specifically looking for in that darkness are fireballs. Standard shooting stars blink out in a fraction of a second, but Lyrid fireballs burn exceptionally bright, often leaving glowing, smoky tubes of plasma called trains that can persist in the sky for several minutes. Finding yourself underneath one of those glowing plasma trains requires a specific viewing strategy, and building that strategy starts with understanding the ancient orbital machinery driving the rocks toward us in the first place. The source of every Lyrid meteor is a single, massive block of ice and rock known as Comet Thatcher, first identified in 1861. This 3D model traces Thatcher's highly unusual path. It takes over 415 years to complete a single lap. At its furthest point, it drifts well beyond the orbit of Neptune, before plunging back down at a steep 80-degree angle to intersect the plane where our planets reside. As Thatcher approaches the Sun, intense thermal radiation vaporizes its icy outer shell. It sheds a continuous stream of dust and rock that remains suspended right in Earth's orbital path. Every April, Earth plows right through that stationary debris trail. We hit these suspended particles at 49 kilometers per second, roughly 110,000 miles per hour. Hitting the thin air of the mesosphere at that speed triggers intense frictional heating. The compressed air in front of the rock reaches temperatures so extreme that the solid surface completely vaporizes. This process, called ablation, creates the glowing column of ionized plasma we observe from the ground. The flash of a meteor is the violent terminal dissolution of primitive material that has been drifting in the frozen edges of our solar system since it first formed. To understand exactly what that primitive material is made of, astronomers capture the light from those terminal flashes and break it down using spectroscopic analysis. This visual breakdown splits the meteor's light into specific emission lines. The Lyrids produce a highly specific barcode, showing an unusual spike in red hydrogen tracers compared to silicon. That tells us Comet Thatcher has preserved a massive cache of volatile ices deep within its core. Because of its long 415-year orbit, Thatcher hasn't been baked dry by the sun. That highly volatile chemical signature creates a debris field filled with uneven, dense clumps. When Earth hits one of those denser clumps, the results are staggering. In April of 1803, residents of Richmond, Virginia were woken up by a shower so intense they actually sounded the local fire alarms. Observers recorded up to 900 meteors falling per hour. The 1803 event was so dense it produced bizarre electrophonic side effects. The massive plasma trails generated very low-frequency radio waves. When those waves hit the ground, physical objects like pine needles and wire fences vibrated, translating the radio frequency into loud hissing and crackling noises for the people standing nearby. The Lyrids usually average around 18 meteors per hour, but the erratic nature of Thatcher's debris means Earth can cross into a dense filament at any time. When you set out to watch them, you have to be prepared for the possibility of a massive celestial storm. To maximize your chances of catching a fireball during the April 22nd peak, you have to prioritize geographic relocation. Urban light domes will easily wash out the shower. You need an elevated area with an unobstructed, pitch-black horizon. Regions like the Envirolab Hills provide natural barriers against city light, granting you a clear view of the lower atmosphere where the streaks are most visible. Once you find your dark spot, you must let your biology catch up. The human eye requires 20 to 30 minutes of total darkness to fully physically dilate and adapt. You need that maximum sensitivity to perceive the faint blues and greens in the plasma trails. Do not look at your phone. A single glance at a bright screen will instantly trigger your pupils to constrict, resetting the entire 30-minute adaptation clock. For navigation, scan the northeastern sky for Vega. It is a massive blue-white star and one of the brightest objects in the northern hemisphere. This serves as the shower's radiant point, the spot where the parallel streams of meteors appear to originate. This star map overlay highlights Vega at the center, but notice the arrows. Do not stare directly at Vega. Meteors coming straight at you appear as short stubs. Look about 45 degrees away from the star. That angle lets you see the debris streaking across the sky in long, dramatic arcs. Recline in a chair, keep your eyes adjusted, and wait. Those tiny fragments of Comet Thatcher have traveled through the freezing vacuum of space for millions of years. In the dark hours of April 23rd, you have the chance to watch exactly how their journey ends.